This is Unit 14, Solution Chemistry, Part 2 Notes. By the end of this unit, you should be able to calculate the concentration of solutions in units of molarity. You should also be able to use molarity to calculate the dilution of solutions, and you should also be able to utilize stoichiometry and molarity calculations. Solutions are composed of a solute, which is most likely a solid, dissolved in a solvent, which is the liquid. The concentration of a solution is the measure of the amount of solute dissolved in a given amount of your solvent. We can identify concentration or describe concentration as the unit molarity, which is the concentration of solutions based on a mathematical formula. So your molarity, which is also known as the concentration, so we can identify concentration in a bracket sort of manner, is the number of moles of solute dissolved in liters of solution. So it's going to be a mole per liter. That's also known as capitalized M for molarity. So those are your molarity units. The higher the molarity, the more concentrated the solution is, or the more solute that is dissolved. So if you have the same volume of water in these four containers, you notice that one is almost transparent. You have a light pink color, then a darker red, and then you have a super dark red color. That means you have increased the amount of solute, most likely a type of red powder, within the same number of liters of your solvent. So if you go from right to left, you're going to increase concentration, or if you go from left to right, you'll decrease in the concentration because you dissolved less solute. So molarity is just the amount of solute dissolved in a solvent, and you just have to make sure you're looking out for your units. So you need to be in the moles and you need to be in the liters. So to perform a molarity calculation, we have to use the formula. Molarity equals moles over liters of your solution. So to find the molarity of a saline solution that contains 0.90 grams of NaCl and exactly 100 milliliters of your solution, we need to make sure that we are in the moles and liters. So we have to do dimensional analysis. So convert grams of NaCl to moles. So use the molar mass of NaCl, which you should know how to do that by now. So 0.9 divided by 58, we get 0.0155 moles. And then we need to convert 100 milliliters to liters. There are 1,000 milliliters in 1 liter. So 100 divided by 1,000, you should get 0.1 liter. Now plugging into the formula, we have 0.0155 moles divided by 0.1 liter, and then rounding to the correct amount of sig figs, which in this case is based on the 100. There's 1 sig fig. The 0.155 would round to 0.2. Capitalize M for molarity, or mole per liter. The second problem, we would have to do a little bit of rearranging because in this case they're asking us for moles. So if we start with the equation, molarity equals moles over liters. To solve for the mole, we have to get rid of the liter, so we're going to multiply both sides. So mole is going to be the product of molarity times liters. Our molarity is capitalized N, so we have 0.70 times 1.5 liters. So the moles of our solute is 1.05, but rounding to the correct amount of sig figs, which is 2, we should get 1.1 moles of our NaCl compound. So just kind of be aware of what they're asking. They can ask you to calculate molarity, which is just moles over liters, calculate moles, which is molarity times liters, or in a pre-P case, they may ask you to calculate the liters of solution, which would be the moles divided by the molarity. So using algebra, you should be able to rearrange that formula to solve for all three variables. If a reaction happens in solution, we can use the molarity equation to help us relate aqueous substances to their coefficients by using a balanced chemical reaction. So for these examples, everything is going to be based on calcium hydroxide reacting with hydrochloric acid to produce calcium chloride and water. Balancing the equation, which you guys should also already know how to do, we have a 1:2 to 1:2 ratio. Okay, so there's two different types of problems. The first one, you can do stoichiometry first and then use the molarity calculation, or in a different problem, you may have to use the molarity equation first and then stoichiometry second. So you kind of have to look at what you're being given in the problem to be able to determine that. If the question is asking you how many liters of something you need to react with another substance, liters is in the molarity equation, so that should probably be the last thing that you do. If you're given 5 grams of calcium hydroxide, we need to be able to relate that back to moles of our HCl, so then we can rearrange that formula and calculate the liters. So if I'm starting with 5 grams of calcium hydroxide, so that's CrCaOH2, we need to be able to figure out moles, because the molarity equation requires molarity, moles, and liters. So you don't have to go to grams. So this is going to only be a 2-bracket type problem. So the molar mass of calcium hydroxide is 74 grams. Relate that to 1 mole. And then do a mole to mole ratio of calcium hydroxide, which is on the bottom, which is 1 mole of that. And that's related to 2 moles of HCl. Multiplying everything across, dividing by the bottom, you should get 0.135 moles of HCl. Keep in mind that whenever you're doing a molarity calculation, every variable has to describe the same substance. That's why we're converting to moles of HCl, because we're given molarity of HCl to ultimately calculate the liters needed for that HCl solution. So then taking our molarity equation, which is the second step that we're doing, if molarity is equal to moles over liters, using algebra, we have to rearrange this formula, which should turn out to be liters is moles divided by molarity. If our mole is 0.135, our molarity is 0.5, dividing the top by the bottom, then rounding to the correct amount of sig figs. The liters that you calculate should come out to be 0.27 liters of our solution. In the second type problem, we're given milliliters, molarity, and they're asking us to calculate grams of calcium chloride. So in this problem, we're going to have to do molarity first. And we need to calculate moles, because the only way to change the substance from HCl to calcium chloride, we have to relate it through a multiple ratio. So molarity is moles over liters. Rearranging this to moles, we multiply both sides by liters. So the mole of our HCl is going to be molarity times liter, which is 3 times 0.075, because we converted the milliliters to liters. Multiplying that together, we get 0.225 moles of HCl. So I can do a mole to mole ratio and then ultimately calculate grams of our calcium chloride using that top equation, 2 moles of HCl, and that relates to 1 mole of CaCl2, and then 1 mole of anything is equal to its molar mass, which in this case is 111 grams. Multiplying everything across, dividing by the bottom, you should get about 12.4875, and then rounding to the correct amount of sig figs, you should get 12 grams of CaCl2. Dilution is the process of decreasing the concentration of a solution by adding additional solvent. So for example, if your Kool-Aid or sweet tea is way too intense for you and your aesthetic tasting, you can add more solvent or water to make that taste kind of go down a little bit. So all you're doing is adding more of your solvent to distribute the amount of your solute that you have already in that solution. So you're not changing the solute particles, you're only changing the amount of your solvent. And you usually do that by increasing it. If you decrease the solvent amount, you're actually increasing the concentration because you'll have more solute within that less amount of volume. So adding solvent is going to increase the overall volume, so it's going to decrease the molarity. So as you increase volume, you decrease molarity, which makes that an inverse relationship, because if one goes up, the other one goes down, and vice versa. So if you look at the picture below, we have a deep blue solution with a specific amount of your solute. If you add solvent, such as water, you go to a lighter blue color because your solute particles are able to spread out just a little bit more, decreasing the concentration. And again, if you relate that to moles or liters, if you increase the molarity, you are decreasing the volume. because they're on the other side of that fraction sign, or you can just think of it as an inverse relationship. To perform dilution calculations, we're going to be using this equation where V1 times M1 is going to be equal to V2 times M2. V1 is the volume of the original solution, M1 is the molarity of the original solution, V2 is the volume of the diluted solution, and M2 is the molarity of the diluted solution. So if you're given a problem of how many milliliters of an aqueous 2 molar magnesium sulfate solution must be diluted with water to prepare 100 milliliters of a 0.4 molar solution, we need to set up the volume or be able to identify our variables. So you're looking for how many milliliters of this original solution. So V1 is going to be our question mark. M1 is 2 molar. You want to be able to prepare a solution with 100 milliliters at a concentration of 0.4. Okay, so here's the thing with dilution. You can leave the volume in milliliters only if both variables are in milliliters. Otherwise, if you convert one to liters, the other one must be in liters. So you need to have similar units for your volume. So plugging our variables into the formula, we have V1, which we're going to identify as just writing the variable, times 2 is going to be equal to V2 of 100 milliliters times our M2, 0.4. So 100 times 0.4, we get 40, and then we have V1 with a 2 next to it. So then to identify or isolate V1 by itself, we need to divide both sides by 2. So 40 divided by 2, we end up with 20, and the unit needs to be consistent with the unit of the other volume, which is 20 milliliters. So the problem with this calculation is we need to be able to identify the original solution versus the final solution. So be very careful of how they're asking the problem. Label all of your variables just like I did, and then you should be able to clearly see which variable you need to calculate. Okay, so have you accomplished the objectives of this unit? If there's any question, please highlight, mark, or make notes of any of the slides that are confusing, or if you need any clarification, and we'll talk about this the next time we have this lecture. Thanks.